Hello, hi everyone. This is Tushar from Rasainika. I welcome you all back to this session. Today I'll be explaining Pinacol Pinacolone Rearrangement. Now this is a very important rearrangement for carbocations. As you know that carbocation is a very important topic in reaction intermediates, and this reaction intermediates cover a lot of weightage in CSIR NET and GATE. So be with me till the end of the session and you will be clearing all your doubts and confusion regarding this rearrangement. Let's move in. Now before we move to the topic, please like, share, subscribe to Rasainika channel. Please do click the bell button. You will be always getting alert and notification for new such chemistry content that we are making. And I'm sure this chemistry content will help you to enhance your knowledge in chemistry and help you to create CSIR NET and GATE. So without wasting further time, let's start the topic. So Pinacol Pinacolone rearrangement, we see this is a pinacol. This is a pinacol. Pinacol. What is this? Basically, it's a vicinal diol or 1,2 diol, and you must be knowing 1,2 diols are not stable in the acidic medium. So when 1,2 diol or vicinal diol is present in the acidic medium, they rearrange to give ketone, and this is what is Pinacol Pinacolone rearrangement. So what is this? So in this reaction, we'll be seeing a vicinal or 1,2 diol in the presence of an acid getting converted to ketone. Now let's see how it is happening. So in the presence of acid, this lone pair of oxygen will attack and it will be protonated. So this OH will be protonated. This OH will be protonated. Now normally OH is not a good living group, but once it is protonated, so it is becoming water. Now this has become a very good living group. Now what will happen? This will undergo, this bond will break and it will be generating a carbocation. Now as in the beginning I have said that this Pinacol Pinacolone rearrangement is very important in carbocations. So the intermediate form is carbocation, and whenever we are doing this reaction we need to consider the stability of the carbocation. Now just I'll remind you quickly, the stability of carbocation for alkyl is tertiary is more stable than secondary is more stable than primary. This is the order of stability for the carbocations. So this is the carbocation that is generated. Now what will happen? This OH minus OH, this OH will push it lone pair and this methyl group will shift. So what we are seeing? A methyl shift. We are seeing a methyl shift over here. So this methyl group will shift over here. So what is the product that will be forming? We will be forming this ketone with a positive proton and will be having this. Okay, now this H can be abstracted from the water molecules that are present over here. This can abstract, so basically we'll be getting this ketone. So what we have seen, we have started with a vicinal or 1,2 diol, and this in the presence of an acid is getting converted into this ketone. So, and what is the most important thing? The stability of the carbocation. Okay. So this is Pinacol Pinacolone rearrangement, and now let's see and use these concepts in some of the questions. Now you have similar to the previous mechanism that we have solved. We are having here 2 OH. Now we need to decide which OH will be protonated first. Now what will be the deciding factor? That OH will be protonated after whose removal the carbocation formed is much more stable. So let's see. For a reference, number it 1 and 2. Now if this is removed, if this OH is protonated and this OH water will be removed, what will be getting? We'll be getting this carbocation. We'll be getting this carbocation. Again, if this is for 1, let's say this is for 1, and if this is protonated. Now if this is protonated, what will be getting? We'll be getting this carbocation. Now you need to decide which of these carbocations are most stable. So you can see here that we are having 2 and 2, 4 protons over here. We are having 4 protons here. So this H through hyperconjugation can stabilize this carbocation. Now let's check from here. Here 2 are there, 2 and one more here, 3. So we are having 3. we are having 3 protons for hypoconjugation. So this carbocation is more stable since it is having more protons for hypoconjugation. So this OH will be protonated. Okay. Now let's protonate this. Once it is protonated, this has become a very good leaving group. Water has become a very good leaving group. It will leave. So a carbocation is generated. So a carbocation will be generated like this. Now, what the mechanism that we have seen? Now this, in the next step, this lone pair of oxygen will be pushing. Now the question arises, which bond will migrate? Which bond will migrate? Either this can migrate. Let's number this 1. Let's number this up 1. Either this can migrate. Either this can migrate. This can migrate 1 or this can migrate. Now, if you remember, in a previous video for Beckmann rearrangement, I have discussed the migratory aptitude. If you haven't seen it, please go and check that video. This will give you information, complete knowledge about Beckmann rearrangement, and we have also discussed some previous year question regarding it. So in that video, I have mentioned the migratory aptitude. So the migratory aptitude for alkyl group is this, where the tertiary group migrates fast, then secondary, then primary. Okay, so the tertiary, since this is a tertiary center and this is a secondary center, this tertiary group will migrate. Now, if this tertiary group will migrate, we'll be getting this. We'll be getting this. Now, positive charge is there and this will be getting neutralized. So we'll be getting this. The final compound is this. The final compound is this. So here 2 things were there. You need to decide, first of all, you need to decide which OH will be protonated. On what basis you will be deciding? You will be deciding on the basis of the stability of the carbocation. Now again, when you are migrating, once the first step is completed, once the carbocation is generated, you will be migrating the group. Now on what basis you will do migrating? On the basis of migratory aptitude. For your revision, I will be writing the migratory aptitude of H is greater than phenyl is greater than R, where R is the alkyl group, and in alkyl group also the tertiary has more migratory aptitude than secondary than primary. Okay. Now moving to the next question, where we have a slightly different reagent to do this. We are having tosyl chloride and pyridine. Now you know pyridine is a base. Pyridine is a base. Pyridine, this is the structure of the pyridine. Pyridine is a base. Now this will abstract the proton. Now it will abstract that proton, after which the carbanion, the negative charge that is developed, is more stable. Now we are having H here and H here. These are the most acidic protons over here. So either this proton can be removed and we'll be getting a negative charge over here, or this will be removed. Now which one is more stable? This one is more stable because it is just attached to one single carbon. So it won't be having that much of electron density due to the inductive effect of carbon. But here, since it is attached to 3 carbons, 1, 2, 3, so it will be having much more electron density. So this is not favorable. So this proton will be abstracted. So once this proton is abstracted, the negative charge will be formed over here, and this negative charge will attack this tosyl group and chlorine will be leaving. So what we have? So what do we have? We have this OH group is here, this OH group is here, and we'll be having O tosyl. Now this O tosyl has become a very good leaving group. Earlier this OH is not a good leaving group. So this has converted this OH, which is a poor leaving group, to O tosyl, which is a very good leaving group. Now this is a very good leaving group. The similar thing will happen. This lone pair will push, and this group, since it is a symmetric system, this will migrate and this will. So eventually we will be forming a 7-membered ring. So we'll be having double bond over here. Eventually we'll be forming a 7-membered ring. Now this will collapse. So we'll be getting this. We'll be getting this double bond. We'll be getting this compound. Now let's say we want to do the similar reaction in the acidic medium. But in the acidic medium, what is the thing? In the presence of acid, this OH will be protonated. This OH will be protonated. In the acidic medium, this OH will be protonated. Now, the question arises, which OH will be protonated? I have again said in the last one, that OH will be protonated after whose removal the carbocation is the most stable. So if this is protonated, this will be removed, so we will be generating a primary one. If this is protonated, if it will be removed, we'll be developing a tertiary one. So which is more stable? Tertiary. So this group will be protonated. This OH will be protonated. So let's protonate that. So let's protonate it and see. Once it is protonated, I'm directly writing the carbocation that is formed over here. Once the carbocation that is formed over here, the same step that will follow. This lone pair of electron is pushed. Now we have here a proton. So this H will migrate easily. So if this H will migrate, this H will migrate, this H will migrate to give a aldehyde over here, and here is a H. Now this H, this proton can be removed. So eventually we are forming a aldehyde. We are forming an aldehyde. So note, depending upon the reagent that is used with this vicinal diol that we have, with the 1,2 diol that we are having, if we are having a combination of base and a leaving group, we need to perform through a carbon ion will be generated or a negative charge will be generated. That will be deciding which will be abstracting. Similarly, if a proton is given or an acid we are doing in an acidic medium, you need to decide where it will be protonated. That is the trick. Now let's move to this question. Here what we have an epoxide, and you know epoxides are in strain system. So in the presence of acid, this will be protonated. Once it is protonated, we have this option where this bond will break. Either this bond can break, and if you are breaking this bond, we'll be generating a carbocation here, or this bond will break here, so the carbocation will be produced here. Now which is more stable? This is more stable. So this is a tertiary system, so this bond will break. Now if this bond is breaking, if it is protonated, and if this bond is breaking, a carbocation will be generated. A carbocation will be generated over here. A carbocation will be generated over here. Now what will happen? Now once this is generated, the same thing. Here we have a proton. Here we have a proton. Now this lone pair will push its electron, and this proton will be migrated. This H will be migrated. So we will be having a carbonyl group over here, and this H is coming over here. This will be protonated. So this proton can be removed. So eventually the product that will be forming, is this. The product that we are forming is this. Now there is a variation to this Pinacol Pinacolone rearrangement which is known as Tifnov-Demjanov rearrangement. Now let's see what is happening. Here in place of this 2OH or 1,2 diol group, we are having a hydroxyl group and an amine group, and we are treating with this acid HNO2. Now what this will do? This will convert this NH2 group to diazonium. This will convert this NH2 group to N2 plus. OH is there, CH3, N2 plus will form. Now this is a very good leaving group. The same thing. Now what we are eventually doing, we are making one group a good leaving group. It is removing. The same thing, this OH group can push its electron or lone pair. This group will go. A carbocation is generated in the first step. Now this lone pair of electrons will be pushed. Now which group will move? We know H, PH and R. So this phenyl group will move. So eventually we'll be having this carbonyl CH3 PH. So this is what we'll be getting. So the product form here is CH3 PH. So here PH group will be. So it's an alternative way where amine is given and you are treating this amine which HNO2, which is an acid. This will convert this to N2 plus, which is a very good leaving group. Okay. Now with this we have completed Pinacol Pinacolone rearrangement. We have seen the questions that are involved in this. I'm sure you will be having a complete idea how these groups are migrating, which proton or which OH group needs to be protonated first. Please like, share and subscribe to Rasayanika for more such content where we'll be getting a lot of chemistry related content that will help you to enhance your knowledge and clear your CSIR NET GATE exam. Thank you all. Thank you for staying with me. And at the down of this video, we'll be getting a link for the note. Please check that link for the note and you will be having the complete set of information that we had discussed today. Thank you all.